think that is really insightful. But also, we have one question from the audience that I would feel is very relevant to this answer that you've given was. So, in your experience, how accurate are the predictive models which are used for disease surveillance? And should we be rethinking our approach given the unpredictable climate changes recently?
Disease models are very good for the, I call them the laptop and mouse click epidemiologists. But actually, you have to see the field conditions. You have to go and visit. That was known as shoe leather epidemiology. Because you see, models they assume as if everything is homogeneous. If you are predicting something, but actual human settlements are not homogeneous, human population migrations are not homogeneous, human breeding spots are not homogeneous. So you have to do a proper survey of the place, you have to monitor the population movement, and then you have to update the model every 2 weeks. A best of the models have a shelf life of 2 weeks only, because there may be another rainfall. You have created a model, you have predicted for next month or next 3 months, but there is a rainfall next week. Your all models will just go for a 6. So these models are good academic exercises, it is a good training exercises, but for policy purposes they can mislead, and they require, ultimately you have to feed the model, and ultimately you have to complement the model with the field work. Now we have become very lazy. We just don't go to the field. We don't see how people are staying. There sometimes you may get a queue. I have an experience. I will tell you just I was posted in a tribal area, and there were heavy malaria, lot of cases of malaria were occurring among the troops who were working in the perimeter. And it was a highly malarious area and a tribal area. And we are having mosquito net, everything we did, but the malaria was not coming down. Then I visited the barracks. They were just next to the forest of teak forest, tribal. And then I found them, most of the toilets were blocked. And most of the troops, I am talking of 20 years back, most of the troops were from rural area. And rural area people are, I asked them, your toilets are blocked, why don't you complain? Well, that doesn't matter, sir. We just go outside in the forest and for a call of nature in the morning and evening. And in the forest, they were going next to the stream where the Anopheles malaria mosquito was breeding. So we were doing everything in the barracks, spraying everything, mosquito nets, but they were getting exposed in the forest when they were going for call of nature. Most of the villagers, they are comfortable. Then I said, okay, now we were giving them Odomos for the face also. I said, now you carry 2 tubes of Odomos. If you have to go there, you have to use in your. So that was the bottoms up approach, because because they were so habituated. So we knew that it is very difficult to break the habits of going to the forest, but keeping that, we customize it, okay. And then in the meantime, we repaired the toilets, we give the water supply, but that would take some time. But this is how you are sitting in the laptop, you are sitting, you are analyzing the data from your armchair. You will miss the thing what is happening in the field, because mosquitoes are also very dynamic. Humans are very dynamic. It is, things keep moving. It's like a game of chess. You three, four pieces you move, the grandmaster won't be able to predict what will happen. Somebody fiddles with the pieces, the whole game changes. So actual, this is, you have to think that you have to go and see, because even the mosquitoes behave differently. And then sometimes they are animals. So animals, some mosquitoes they prefer the animals, some prefer the humans. Like in the Anopheles culificis, the rural vectors, they prefer the animals. So if you have a lot of animals, the humans will be spared. But this Aedes, they prefer human blood. So Aedes is a very effective vector that way. That is for Aedes aegypti. There is another vector, Aedes, which can also transmit dengue, chikungunya, and Zika. That is Aedes albopictus. They are slightly away from the residential area. They will be found in parks and other things, places of recreation, fountains, parks. So that is also very place for gathering and other things. So these are some of the challenges, and what we are having the problem now, as you have also said about vaccines and other thing, virus, vector vaccines. Earlier we used to have the field work. We used to have entomologists who will study the insects. So now we are just having one end is the virus, other end is the vaccine, and there is a whole goalpost which is without a goalkeeper. That is the field workers. So we have to go down to basics, because vaccines are also not predictable. I mean, the vaccines are not predictable like models. They are a good prop. They are good to have in the toolkit, but they are not the panacea that it will save against all. And dengue vaccine is a bigger challenge because of the four strains.
I think that is a clear explanation, and I think a lot of points to be considered, like right kind of awareness. Then some certain policies also should be in place for this. Now, which comes
Involvement.
to, yeah,
Involvement
sorry.
of the community is important because you
Mhm.
see, in a large country and large population, it is not possible for the health inspectors or the sanitary inspectors or the health department workers to. So once you involve the school children, once you involve college children, they, in the hostels also they